Hi guys, in this video I'm going to be talking about how to find the vertical and horizontal asymptotes, the graph of a rational function. Interesting printing here that went on. This is supposed to be just 3 over x plus 4. This graph over here is supposed to be x squared over 2x plus 1. Not sure how that happened. It doesn't look like that on the computer document, but it printed funny. So here's what we're going to do, okay? If we want to find the vertical asymptote, let's do that first. That's always our first step. Step 1, set the denominator equal to 0 and solve for x. So I'm going to do x plus 4 is equal to 0. That means that x is negative 4. Okay? My vertical asymptote is at x equals negative 4. Okay? I want to prove that to you right now. Before I go any farther, I'm just going to go graph this thing. Okay? 3 divided by, notice the parentheses, I need to group everything in the denominator over x plus 4, right? And when I graph this, look at this, okay? You see the vertical line. That's weird. We'll talk about that in class, but you'll see that it's at 1, 2, 3, 4 to the left is kind of where that thing shoots upward and shoots downward, doesn't it? Okay? So my vertical asymptote was there. The reason why is because if I put a negative 4 in, I'd have negative 4 plus 4 on the bottom. That would be giving me 3 divided by 0. I can't divide by 0. That's a problem. Okay? On this problem, the vertical asymptote is found whenever I take 3x minus 2 and set it equal to 0. So that would be 3x is equal to 2. That means x is at 2/3. So my vertical asymptote is at x equals 2/3. I could prove it to you again. We would see the same graph, except instead of going left 4, we'd go right 2/3. Over here, 2x plus 1 is equal to 0. That means 2x is negative 1. That means x is negative 1/2. So I have a vertical asymptote at x equals negative 1/2. Okay? So there's the first step to the problem. The second thing I asked you to do is find the horizontal asymptotes. And so this comes from comparing the powers. Remember, what value am I going to level off at? And so all I'm going to do is this. I'm going to say, okay, what's the degree on top? The degree on top is 0. And the degree on, if I'm just comparing degrees, okay, 0, x is on top, x to the first power on bottom. That's bigger on the bottom. And so I go back to this little chart here that we made, and I say, okay, if it's bigger on the bottom, that would be this situation right here. Smaller on top, bigger on the bottom. The horizontal asymptote is going to be at y equals 0. Okay? Look, I look at the picture and look where it levels off. It levels off at 0, doesn't it? If I go to the table and I start looking at the table, man, these values are getting really close to 0, but I bet I never hit it. Right? How about this one? This one here, I look at the powers of x and I say, okay, if I look at the degrees, there's the biggest one right here. It's x to the first and x to the first, right? And if it's the same power, that's the situation where I just cross this out and I see right there, it's 2/3. So the horizontal asymptote on this one is going to be at y equals 2/3. That's where it's going to level off. And then over here, I have x squared over 2x plus 1. And so if I compare the degrees, I have a square on top and I have a first power on bottom. It's bigger on top than it is on the bottom. And in that situation, we know that it just continues to grow. This thing is going to shoot upward. And so in this case, there is no horizontal asymptote. So hopefully that makes sense. You're just going to need to use that table over and over again until you memorize it. This one right here, okay? And eventually it'll click for you, okay? But if all else fails, you throw it in the calculator, and we do something like this. We say, okay, I have, like on this example here, I have x squared divided by the quantity 2x plus 1. I see that the issue happens right there. See, there's the negative 1/2 that I was looking for. I can go second, calculate, and I can calculate a value. And if I put in negative 0.5, negative 1/2, notice that it doesn't even give me a y-coordinate. If I go to the table and I try to find it, okay, I might have to do some table setup, start at 0 and go by halves. But notice at negative 1/2, it even gives me an error message. So I might even see that on the table. So I can always check it with a picture, in other words. Hopefully that's enough to get you going for today.